Hi, and welcome to the first video covering Day 2 material for Section 2 of Pharmaceutical Calculations. In this video, we'll be talking about reconstituting dry powders and how to manipulate concentrations of various drug preparations. We have a conversion table here. It should be the same as for the last slide packet. You need to memorize it for the assessment. Okay. In some situations, drugs are going to be shipped to the pharmacy as powders that need to be constituted with liquid before being dispensed as a solution, where a constitution is just dissolving the drug powder into solution. And this might occur because the drug would maybe degrade if stored for long periods in solution, or maybe because different concentrations need to be prepared for different types of patients. It might also occur when a solution is being prepared from a solid dosage form for patients who have trouble swallowing. We already know that a drug concentration is reported as the mass of drug, total amount of drug, in the total volume of solution. The only thing to really remember when dealing with constitution problems is that the solution volume is made up of two different parts. There's the volume of the liquid solvent and the volume of the drug powder, and these sum together to give the total solution volume. Okay, so we have an example of a constitution problem here where 77 mils of water was used to constitute a drug powder, and a 100 ml solution resulted that had a drug concentration of 400 milligrams per 5 milliliters, so 400 milligrams per teaspoon. And we first of all want to know what's the volume of the drug powder. Well, if the solution volume is the sum of the solvent volume and the drug volume, then we can rearrange that so that the drug volume is the solution volume minus the solvent volume. And so we're given 100 mils for the solution volume, 77 mils for the water. Subtracting, we get 23 mils, which we can attribute to the drug powder. In the next question, we have, what's the mass of drug in the powder? Well, assuming we use the entire powder to make the 100 ml solution, which I think is a good assumption, we can take the drug concentration that we're given of the solution, which is 400 milligrams for every 5 milliliters of solution, and we can use the solution volume. We wouldn't use the solvent volume for this because the denominator in a concentration is the solution volume. So we can use the solution volume on the bottom of this proportion and ask how many milligrams of drug there would be in that volume. And so multiplying, dividing, we get 8,000 milligrams of drug in the drug powder. Finally, what would the drug concentration be if 100 mils of water were added to the powder instead of 77 mils? So this is a constitution error, and we can determine what the drug concentration would be if instead of putting in 77, you put in 100. So the drug mass we calculated already, it's 8,000, and we calculated the mils of drug powder, just 23. And this time, instead of having 77 plus 23 to give 100 mils of total solution, we have 100 mils of solvent. Okay, so we're breaking up that solution volume on the bottom into drug plus solvent volume to account for the difference in the amount of solvent added. So 8,000 divided by 123 instead of by 100 gives 65 milligrams per milliliter. All right, go ahead and take a look at the list of calculations problems on the next slide, and I'll work them out in the next video.